Hi, this is Victoria Morella, and this is my Lab 7 video submission for ENME351. Starting out with exercise number 1, we have a circuit schematic of a non-inverting op-amp, and as you can see, we have a voltage divider right here, and because it is an ideal op-amp, we know that V minus is going to equal V plus, and so we can use this to get a voltage divider equation, and then we can sub in V in for V minus, so we get this voltage divider equation, and then solving for the gain is just VO over Vn. So solving through, we get a gain of 1 plus R2 over R1 for this non-inverting op-amp. For exercise number 2, we have a voltage follower circuit. So here we have our op-amp, our potentiometer to vary Vn, and then the 4 analog pins reading in the 4 different voltages. For my Arduino code, we just have the 4 analog reads for those voltages, and we're going to create a string of those voltages, print it, so processing can read these voltage strings, and then delay 50 milliseconds in between the data points. And when we run this, we'll see that V in, V minus, and V out will all be the same for every V in, but for V out, it isn't going to follow when it's below 2 volts because Arduinos are only between 0 and 5 volts and not -5 to 5. For exercise 3, we added in a voltage divider here, which will make the non-inverting input V plus equal to 2.5 volts. And this is important to do because the Arduino can only output voltages between 0 and 5 volts, so we need a ground that is in between that. And then over here we have a 10 kilo ohm resistor and a 1 kilo ohm resistor, and this makes the gain of the circuit -10. And we use the same Arduino and processing code as we did for exercise 2, and then when we run this, we can see that when V minus is at a low, the V out is going to top out at 4 volts, and V minus is going to be slightly lagging in magnitude from the input because there's a resistor between V in and the inverting input, and then as we top out V in, V out is going to bottom out a little below 2 volts, and this is because Arduinos can't handle large inputs because of the problem with the it's only 0 to 5 volts. And then as you can see, when V in is very close to the ground, that's when you're going to actually see the inverting amplifier working. That's when V out is going to be -10 times that V in. But this only really works at small inputs around that 2.5 ground line. For exercise number 4, when we derive the equation for the integrating amplifier, we know that for an ideal op-amp, V plus and V minus should be the same, and since V plus is connected to ground, that would mean V minus is equal to 0. So at this node right here, we are going to apply KCL. So right here we'll have this equation where V in minus 0 volts over R equals 0 minus V out over ZC, which is the impedance of a capacitor. And then when we solve this through, we get this equation that V out is equal to -1 over J omega C R times V in, which we can translate to this integrating equation that V out is equal to -1 over RC times the integral of V in dt. And so the gain in this circuit is going to be -1 over RC, which in our case, with our values, is going to be around -21.3. And then for the circuit right here, it's going to be the same as exercise 3, except we swap one of the resistors for a 4.7 kilo ohm, and then we added the 10 microfarad capacitor in here. So we're going to run this processing code again. And what we see is when V in is right around this 2.5 ground, we're going to see that the gain of V out is pretty large, which is around that -21 range. So this is acting exactly how it should be. But when we increase V in, up to like 5 volts, we'll see that V out bottoms out a little below 2 volts. And this is because the Arduino is only working between 0 and 5 volts. So it's not going to work very well when the voltage inputs are too high above ground. So it's working best when we're around that 2.5 volt.